All right, so let's take a look at our schedule. Today is our last lesson of the semester. Officially, the last quiz is assigned today, but I did give it to you Friday. But did everybody get my email? Some people got it. Okay, if you didn't get it, make sure you check your email. I messed up some of the wording in the last question. Didn't make any sense at all. So. Sure. Yeah. Yeah. If you could guess what I meant, that's fine. Yeah.
You meant height, not population.
Right. I meant height, not population. Yep. Yeah. So. Yeah. So a fixed version was attached to that email, and it's also posted in Moodle in the class announcements. So if you want to check that. Yeah. So if you want to hand that in today, I will have it back to you on Wednesday, but it's not officially due until Wednesday. Okay? So if you need another day, you can take that. Wednesday, we'll work on our review for the final exam. You have 2 study guides or 2 sets of practice problems for the final exam at the end of your packet. And then your final exam is on Monday, the 21st, from 8 to 10 in this classroom. I don't remember. I'm going to guess 8 to 9 questions. Yeah.
That's the same as in the other test then?
Yeah, it like might be like 20% longer than another test.
Okay.
Like a little bit longer, but not much. And your final reflection project, just bring that with you to the final exam. Okay, so in this class, we're going to look at a few theorems about definite integrals, and we're going to think about the area between 2 curves. So again, take-home quiz. I gave it out Friday. If you haven't gotten one, make sure you ask me for one. All right, so here's some questions. What if the limits of integration, the a and the b, right? What if they're both the same number, and what if the smaller number is on top? So let's think about what if they're both the same number first. So I want to do the integral from a to a of f of x dx. So this is saying find the area underneath the curve f of x from x equals a to x equals a. Right, so how much area is there under a curve there?
Something times 0.
Y times 0.
Because there's no 1 minus 1 is 0.
Yeah, the width of your rectangle that you try to build under that curve, the delta t would be 0. So if you try to make a rectangle under the curve there, the width would be 0, so its area has to be 0. So I'll just draw, right here, I'll draw a picture of it. So if I want the area of that line, basically, a line has no thickness, so it's got no area. All right, now what if I want to do the integral from b to a? Almost all the integrals we've seen so far, the smaller number has been on the bottom. But what if I put the bigger number on the bottom? Yeah, so we define that, which means we just made a choice about what this was going to mean. And this means you put a negative in front of the integral and just evaluate it from a to b. So you just do it the way you normally do it, but then make it negative. And you can think of that as this rule as going backwards in time when you're trying to find the distance traveled under a velocity curve. So if you wanted to know how far did you travel from t equals 5 to t equals 3, so you're thinking about it in terms of going backwards in time, so you put a negative. All right, so let's apply a couple of these integrals. What is the integral from 3 to 3 of x plus 2 dx? 0. No work needed, right? There's no, the thickness under 3 to 3 is 0, so there's no area. All right, the integral from 1 to 0 of the square root of 1 minus x squared dx. So I put the bigger number on the bottom, which is a weird way to write it. So instead, I'm going to put a negative and then rewrite it as the integral from 0 to 1. And then I gave you a picture of the square root of 1 minus x squared dx from 0 to 1. So I'm looking for this area. What would that area be?
Fourth.
1/4 pi r squared, and what's r in this case? 1. Yeah. So this is pi over 4. So this is negative 1/4 pi times 1 squared, negative 1/4. Pi, sorry. Negative pi over 4. All right, questions there? All right, so let's think about a couple of more theorems here. If you think about the geometry of areas, these should be fill-inable. So if you add two functions together, that means you're just adding their y values, right? So if I want to add them together and then take the integral, which means take the area under the big sum, you can just take the area under each one and add them together separately. So this could be the integral from a to b of f of x dx plus the integral from a to b of g of x dx. Same for subtraction. Okay, so if you have a function f and you multiply it by c, that means you're going to multiply all the y values by some constant c, so you're going to stretch f. And then you find the area underneath it. That would be the same thing as finding the area underneath f and then multiplying it by c. So you can either stretch the function, then find the area underneath, or find the area under the function and then stretch that number. And so far, these first three correspond to derivative rules, right? So the derivative rules are similar. If you want to take the derivative of the sum of two functions, you can take the derivative of each one separately. Same thing with a constant coefficient and for differences. But this third one is a little harder to picture. If you want to take the integral from a to c of f of x dx plus the integral from c to b of f of x dx, it helps to have a picture of that. So that's what I have right here. So I've got a random function f of x, and then here's a and b, and you put c somewhere in between. So if you take the integral from a to c, right, that's this area, and you add to that the integral from c to b, which is this area, that would be equivalent to doing what? You just can go from a to b directly. Yeah. This is the integral from a to b of f of x dx. In this picture, it's quite clear because we put c in between a and b, but it actually works even if c is not between a and b because of this whole rule with the negative thing, right? If c is actually the bigger number, then you get the negative thing, so it actually still works even if c is not between a and b. All right, so let's apply all our rules here for one integral. I want to take the integral from 0 to 1 of 5 minus 3 square roots of 1 minus x squared dx. So I've got a subtraction in there, which means I can break this up into two separate integrals. So this will be the integral from 0 to 1 of 5 dx minus the integral from 0 to 1 of 3 square roots of 1 minus x squared dx. And then I have a constant coefficient here of 3. So I can use this property where you can take that c and just pull it right out front of the integral. Yep, I took this 3, and you can move it right outside of the integral by this property right here. Yep. All right, the integral from 0 to 1 of 5 dx, what would that be? It's 5, yeah, you can just draw yourself a picture, right? 5, y equals 5 is just a horizontal line, right? So I'm trying to find the area under that line from 0 to 1. So you're looking for this area. So its base is 1, height is 5, so its total area is 5. So this is 5 minus 3 times. This is an integral we just did a few minutes ago, right? The integral from 0 to 1 of radical 1 minus x squared dx came out to pi over 4. So we get 5 minus 3 pi over 4. All right, that's it for your lecture. You can start your activities.